Okay, hi guys, let's begin with today's class. Now today's class is based on elliptic curves and how do you solve a problem with elliptic curves. Okay, so elliptic curve is basically what an elliptic curve can be defined over real numbers, it can be defined over prime numbers. And how can we, what is the general equation of elliptic curves? The general equation is y square is equals to x cube plus ax plus b. Okay, this is the general equation or the general form of elliptic curve, and it can be defined over real numbers and it can be also defined over primes. Okay, so basically we can also write this equation as y is equals to root over x cube plus ax plus b also, right? So we can write like this also. So what does this mean? This actually means that the elliptic curve is symmetric about y equals to 0. So this basically means that this is the coordinate x and y, right? If say this is the coordinate x and this is the coordinate y, right? So what does this mean? Y equals to 0. So y equals to 0 is the horizontal axis, right? So the elliptic curve is what? Symmetric, right, about the horizontal axis. So the curve about x axis below x axis would be symmetric, right? So this is the whole point of view. Now what is my motive, or how is the question going to come? Say they are going to say find the points on elliptic curve defined by E11 1,6. Suppose this is the question given to you, right? So what does this mean? This means that a is equals to 1 and b is equals to 6 from the general form that we had written few minutes ago. And what is this 11? I had said already few seconds ago that your elliptic curves basically deals with what? It deals with either real numbers or it deals with over either the primes. So here what is 11? So we are going to operate it over mod 11. We are going to operate it over mod 11. So I can rewrite this whole equation as y square is equals to x cube plus x plus 6 mod 11. I can rewrite this whole equation, right? So how do I find the points? I need to find the points, right? So how do I need to find the points? I need to find the points, and we are going to operate it, since we are going to operate it over mod 11. So the numbers would be from 0 to 10. Okay, the 0 to 10. X's value would be 0 to 10. Y's value would be from 0 to 10. Okay, and what do I need to find? I need to find the values of x and y, the values of x and y such that it is LHS equals to RHS. Okay, the LHS equals to RHS, then that point will lie on the elliptic curve. Then that point is going to lie on your elliptic curve. That is my motto. So what are the values of x? So what are the values of x, right? So x cannot take all the values, right? X, as I have already mentioned, that x can have the values from 0 to 10. Okay, so RHS ka formula is RHS side was what? It had x and it had x cube plus x plus 6 and it had mod 11. It had this, right? So, and the values would be from 0 to 10. Let's write all those. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so we have all these values, right? So what I'm going to do, simple, I'm just going to put the x's value over this equation. I hope you know how to find mod's value. If not, then please remind yourself once again. So 0 ka value would be 6, 1 ka value would be 8, 2 ka value would be 5, 3 ka value would be 3, 4 will be 8. Okay, 4 will be 8, 5 will be 4, 6 will be 8, 7 would be 4, 8 would be 9, 9 will be 7 and 10 will be 4. Now this is my side of it is the side of my RHS, right? RHS. Okay, RHS. Okay, now let's find for LHS also. So it's y, and what is the equation? It's y square and it is mod 11. Okay, so again the y's value would be from 0 to 10. So 0 1 2 3 4 5 6 7 8 9 and 10. Okay, so all these equations, sorry, all these numbers. Now let us put all these values over this. Now this is very simple. 0 would be 0, y square mod 11, and 1 would be 1, 2 would be 4, 3 would be 9, 4 would be 5, 5 would be 3, 6 would also be 3, 7 would be how much, minus, and this would be 5. Okay, 8 would be 9, 9 would be 4, and 10 would be 1. Okay, now let's zoom it out a little bit. Yeah, you have all these values. A little bit more, let's zoom it out. Okay, yeah, so these are the values of LHS and RHS. Now I'm just going to map from RHS till LHS. Now what is the thing that I'm going to check? Like as I said few seconds ago, my target would be to do LHS equals to RHS. Then that point is going to lie where? That point is going to lie in my elliptic curve. Okay, so let's find it here. Okay, let me check where 6 is present. I'm going to check this value, whether this value lies in my LHS or not. Okay, so let me check whether 6 lies here or not. Okay, whether it is present in the RHS side. Is there 6 present in the RHS side? Let's just check. No, there is no 6 present in the LHS side, so this is rolled out. Okay, this is rolled out. Now next value is 1. For 1 it is 8. Do I have 8 in the LHS side? No, there is no 8 in the LHS side, so this is also rolled out. Okay, now next what I need to check, I need to check 5 for 2's value, right? I need to check 5 for 2's value, right? So do I have 5? Yes, I have 5 for 4. I have also 5 for 7, right? So how am I going to write it now? That is the main problem, right? So I see that 5 is present in the LHS side, and we have 2 5s, for one is for 4, another is for 7, right? So how am I going to write like this? So if the x's value is 2, right? If the x's value is 2, right? Here x's value is 2, right? Correct or not? So x's value is 2. I have RHS 5 similarly, right? So then we have it for this thing also, 7 also, right? So what I'll write is, I'll write simply the points like this. It would be 2, 4, and it would be 2, 7. I hope it's very much clear. So I've just written the x's value 2 times, which is 2, and I have 2 y's value for the same x's value, so I just written that only. Okay, 4 and 7. I hope it is very clear to you guys, right? So next what value we have? Next value we have is 3, which is 3, right? So we have 3 over here, correct? So what is the value for 3? It is 3, what? It is 3, 5 and 3, 6, this, right? 3, 6, correct? So in this way you'll be able to find all the values as well. Like I'll just do another one. So for 4 we have 8, right? So do we have 8 over here? No, we don't have any more 8, right? So hence this is rolled out. Okay, this is rolled out. Then we have 5. For 5 we have 4, so we have 4 value here. So 2 ka 4 we have, another 4 we have for 9. So what would be the value? It's very simple. We have 5, 2. We'll have 5, 2. And we'll have 5, 9. As simple as that. Okay, so in this way you'll be able to map all the values. I'll just write in between. Okay, that would be much more easier for you guys to write it down. 2, 7, 3, 5, 3, 6, Okay, then you have 5 comma 2, 5 comma 2, 5 comma 9, then you have 7 comma 2, 7 comma 9, 8 comma 3, 8 comma 8, 10 comma 2 and 10 comma 9. Okay, so the corresponding values in the elliptic curves. Okay, these are the points that lies in the elliptic curve, that lies on the elliptic curve. Okay, so I hope this is clear to you guys. Let's just once just check what is there in the PPT. Now this is what is the just a second. Yeah, this is the general form of elliptic curve. This is the general form of elliptic curve. Y square is equals to x cube plus ax plus b. We have already known that thing right now. Okay, so you can see how this elliptic curve is being represented over here when y square is equals to x cube minus 1 and when y square is equals to x cube plus 1. How this whole thing changes, your elliptic curve changes. Now this is a simple example of elliptic curve where y square is equals to x cube plus 2x plus 3. Okay, now you know the values. We have already done one example related to it. Now here x is equals to 0, y square is equals to 3. So no solution like we did for, I mean, rolled out. That's the whole point here also. Then we have x equals to 2. So like it's for mod 5, so hence the x's value is still 4, right? It's been equated like that only. So you can check this out, this particular PPT. You can check it on your own. I had already explained what is an elliptic curve. I hope it is easily understandable by that. That's it, right? Okay.